Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. I hope you had a great week. So, Happy New Year. Welcome to the first episode of 2022. Today, we are having a great interview. But before we get started, remember that Let's Talk Micro is available on Apple Podcasts, Spotify, Amazon Music, Google Podcasts, Stitcher, Overcast, TuneIn Radio, Pandora. Wherever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow. I like to post pictures of organisms, and also I like to give previews of when the episodes are coming. So go ahead and follow. So today we are having an interview, a great interview, I might say. So let me start by asking you all, have you heard of complexes in bacteria? I'm sure you have. Those are a group of organisms that are closely related and they are put together in a group. For example, the Enterobacter cloacae complex, right? It has Enterobacter absuriae, cloacae, cobi. So did you know that there's a Staph aureus complex? Well, if you're a clinical microbiologist, you might know of it. Maybe if you're a clinical lab scientist, you might know as well. So these are bacteria that are closely related to Staph aureus. One of these is Staphylococcus argenteus. This organism was originally isolated from Australia, and it closely resembles Staph aureus. It has been differentiated by whole genome sequencing, and few instruments that we routinely use in clinical microbiology can identify it. It has been identified by Malditov-Brucker. On the plate, it also closely resembles Staph aureus. It is catalase and coagulase positive, beta hemolytic on blood agar. So one difference is that Staph argenteus isolates have been found not to have the yellow pigment that Staph aureus typically has. It lacks the staphyloxanthin gene cluster, which encodes for this pigment. This makes us think that what if we have one and we call it Staph aureus? Those of you that work in clinical micro, typically in a lab, most of our Staph aureus isolates, they are isolated presumptively, right? So we do our catalase, coagulase. We use commercial kits like the Bacti-Staph, which is very popular. And then, so we have our hemolysis. It is coagulase positive. We call it Staph aureus, and we're done with it. If anything deviates from this path, then we go ahead and use another method of ID, like Vitek, Malditov. So this is what we do in our labs. So this organism, Staphylococcus argenteus, it is not identified by the Vitek system. And reports show that it has been identified, like I mentioned, by Malditov-Brucker. If you set it up on another system, it might identify it as Staph aureus. So what do we do with this? When do we know if it's Staph aureus or not? Well, on today's episode, I have two great guests. They were involved in an article that was published in the Journal of Clinical Microbiology for the American Society for Microbiology. This article talks about a study that was performed on 22 isolates received by two reference laboratories, Public Health Ontario in Toronto, Canada, and Mayo Clinic in Minnesota, here in the US. They were sent for identification and antibiotic susceptibility testing. According to the article, 3 isolates that arrived at PHO, Public Health Ontario, were identified as MRSA and were sent to PHO for a confirmation of this ID. These 22 isolates ultimately were identified as Staphylococcus argenteus. This organism has been implicated in bacteremia, bone, and joint infection. It also has been shown to cause toxin-mediated foodborne illnesses, and it has virulence factors in common to those of Staphylococcus aureus. For those of us in the lab, What are the challenges for us? How does misidentifying this organism as Staphylococcus aureus affect the patient? What about susceptibilities? What about those breakpoints? Are they the same as Staph aureus or are they different? Well, let's go ahead and listen to the interview. So on today's episode, I have two guests that are here to discuss an article titled Phenotypic and Genomic Profiling of Staphylococcus argenteus in Canada and the United States, and recommendations for clinical result reporting. This article was published in the Journal of Clinical Microbiology of the American Society for Microbiology. So with me today, I have Dr. Robin Patel and Dr. Audrey Schuetz. They are co-directors of the Bacteriology Laboratory in the Mayo Clinic. All right, so welcome to Let's Talk Micro.
Thank you.
Thank you.
Okay, so let's just start with a brief summary of the article, Dr. Patel.
Yeah, first of all, thanks for having us here today. Just wanted to give a little background about the article and then tell you about what we did on our major findings. This was a collaborative effort between researchers at Public Health Ontario in Toronto, at the University of Toronto in Toronto. Both of those places are in Canada, and at Washington University in St. Louis, as well as, of course, Dr. Schuetz and myself and our colleagues here at Mayo Clinic in Rochester. And we had all been struggling with a new species, or relatively new species, called Staphylococcus argenteus, which was formerly known as Staphylococcus aureus clonal complex 75. And what the big challenge for us was identification of this particular species, since it used to be a part of Staphylococcus aureus, but now is a species unto itself. And also how to deal with antimicrobial susceptibility testing. So we got together and we combined our isolates that we thought were Staphylococcus argenteus, and we ended up with what we believe is the largest collection of Staphylococcus argenteus isolates in North America. And then we looked at identification challenges as well as susceptibility. So the isolates that we studied were collected between 2017 and 2019, and there were 22 isolates in total. We looked at routine identification methods such as biochemical identification methods, matrix-assisted laser desorption ionization time of flight mass spectrometry, and even 16S ribosomal RNA gene analysis. And all of these methods have challenges in terms of confidently distinguishing Staphylococcus argenteus and Staphylococcus aureus. And so in order to know with certainty what we were dealing with, because this was important, we subjected all of the isolates to whole genome sequencing analysis and used a number of analytics to confirm, based on that sequencing data, that indeed these 22 isolates were Staphylococcus argenteus and not Staphylococcus aureus. We looked at where the isolates came from. We didn't look in detail at the clinical presentations, but 7 of the 22 isolates were recovered from sterile sites, 11 from non-sterile sites, and then 4 were from surveillance screens. We found that the isolates behaved in many ways like Staphylococcus aureus. In other words, some of them carried MECA, some of them carried virulence determinants that you can find in Staphylococcus aureus, such as Panton-Valentine leukocidin and TSST1. And then we examined the question of what to do about antimicrobial susceptibility testing of Staphylococcus argenteus, and we made some recommendations to clinical laboratories concerning that, as well as identification of this interesting and challenging species.
Okay, so as far as any methods of identifying it besides moldy tough, and I remember like most labs, especially the ones that I have worked at, you know, they just get sub to the moldy tough, and that's about it. I mean, smaller labs, they result to either like the Vitek or other instruments. And mostly Staph aureus, you know, gets identified. You see the hemolysis, and like your coagulase is positive, you call it, and you're done. And then again, a lot of times, even though Staph aureus is mostly, you know, has the yellow pigment, some of the ones that we come across, they do not. So besides MALDI-TOF and gene sequencing, is there any other method that we can use in the lab to identify it?
Well, I guess I can start with, I guess, highlighting what you've mentioned, what doesn't work. And it's true, the morphology, colonial morphology doesn't work, not very reliable, and it depends upon the media that you're looking at as well and timing. As well, the biochemicals and the kit-based approaches not working. These organisms are too closely related to Staph aureus to differentiate them. So I do think that depending upon which database you have and which MALDI company you use, MALDI instrument you use, that's probably the closest possibility for many laboratories to use for a diagnosis of this. But again, it depends on the version that you use and the company, because as far as the closest availability, this offers a combination of closest accuracy in diagnosis and availability of the instruments in laboratories. So that's really short of a targeted PCR or other methods like we mentioned. That's going to be the one that's most available.
Okay, thank you.
Yeah, and I can jump in there a little bit. I think it's just important to keep in mind that this species is out there and is closely related to Staphylococcus aureus. There's actually another one, Staphylococcus schweitzeri, that is also in this group of new species that used to be Staphylococcus aureus, but now have their own name. That one we don't see frequently in clinical practice, so that's encouraging, but still, from an accurate identification standpoint, it needs to be lumped in here. And I think whatever system you're using, you have to understand what would my system call Staphylococcus argenteus if I ran into it. And if you're using, for example, MALDI-TOF mass spectrometry, it needs to be in the database to begin even entertaining the possibility that it would be called. But even if it is in the database, it might be misrepresented as Staphylococcus aureus depending on how things are configured. So you really have to look at what you're doing locally. Unfortunately, as Dr. Schuetz mentioned, none of the other sort of conventional identification methods are going to be terribly useful for identifying this species. So, you could use whole genome sequencing like we did in this study, but I think that's going to be a little bit of overkill for identifying this species. There are genetic targets, such as the NUC gene, and there are others as well, that are sufficiently different between Staphylococcus aureus and Staphylococcus argenteus that PCR assays can be designed and used to differentiate these species. But that is still complicated in terms of identification. So I think the most important piece is awareness that this species is out there, and it could be identified as Staphylococcus aureus or not, depending on which system you're using. And one needs to think about how to address that and how to deal with this in clinical practice.
Okay, thank you. So this brings the next question. So from the article, it says, so Staph argenteus has been seen in, anything from skin lesions, bacteremia, joint and bone infection. So since based on the method of identify it, if we report it as Staph aureus, because we don't have the capabilities of properly identifying it, would this negatively affect the patient as far as you know?
Yeah, that's a really good question. We're seeing more and more species of bacteria in general being described over time. And in some cases, those new species are clinically relevant. In order for us to really understand what it means that you found one species versus another, laboratories need to be able to identify those species, because if we're continuously calling something by a wrong name, we'll never get to a point of learning if there are those differences. Clinically, Staphylococcus argenteus can cause infections similar to those caused by Staphylococcus aureus. So it's likely that reporting it as Staphylococcus aureus would not cause patient harm or negatively affect the patient, as you asked. But it's not actually Staphylococcus aureus. So this is technically incorrect. And again, unless we properly identify the species, we'll never really understand its clinical significance, or maybe differential clinical significance, if there is any, compared to Staphylococcus aureus. One way to address this is to call out Staphylococcus aureus complex, which includes Staphylococcus aureus and Staphylococcus argenteus, and acknowledges that we're not teasing apart which species it actually is.
Okay, thank you. The article mentions that there is evidence of Staph argenteus being a colonizer. Do you know where in the body?
Yeah, that's another really good question. We did have some isolates that were screening isolates that were part of the study. And we know that Staphylococcus aureus colonizes the anterior nares. It can be found on the skin. It can be found in other parts of the body as a colonizer. But to the best of my knowledge, we don't have detailed studies on where Staphylococcus argenteus is when it is a colonizer. Dr. Schuetz, I don't know if you have any other thoughts on that piece.
No, I don't. I think we're in part encouraging continued research in this area, in part because we need to find these answers more. And so this is another good example of why, even though clinically we don't think it's of huge importance to really differentiate argenteus necessarily from the Staph aureus. It's still going to be important for us to gain further knowledge by trying to get to that species level.
So I know that this was mentioned on the article, but can you, for us that the medical laboratory scientists, this is one of the most important things when we're dealing with this organism, the breakpoints. So can you talk more about the oxacillin breakpoints for this organism?
Oh, that was a neat aspect of this study as well. So we looked at molecular resistance determinants, as well as, of course, the phenotypic testing too, because we wanted to know that even though we knew this was a coagulase positive organism and within the complex, we needed the data to support the fact that the oxacillin breakpoints are the correct ones indeed to apply from Staph aureus. And we were able to support that with the whole genome sequencing data and the MEK PCR we used by confirming that the MEK positive isolates indeed had the MICs that were within the Staph aureus oxacillin MIC range and the resistant range. So we had the opportunity of bringing this data to the Clinical and Laboratory Standards Institute, the AST subcommittee that meets twice a year on this, and they were able to look through our data and use that in order to put this into their document as a recommendation that the oxacillin breakpoints should be used. I mean, we really need to make sure that we as labs are certainly not that we're letting our clinicians know that this is one of the Staph aureus complex organisms, and not just reporting it out as Staph argenteus without some sort of a modifier or explainer that it's within the complex, because we want them to take this organism seriously, as it is indeed a part of the Staph aureus complex, and also important that we apply those correct breakpoints so that the clinicians are appropriately making therapy decisions as well.
So what about for clinical laboratories that do have access to this particular MALDI-TOF? Would you recommend that instead of presumptively identifying Staph aureus like we've been doing, just run it through there to properly identify it? Or, I mean, depending on I guess that'll be like a lot of samples to place through the MALDI-TOF. So would you recommend this?
Yeah, it gets tricky, right? There are a lot of different MALDI-TOF possibilities that are out there. There are different vendors, and then there are different databases and different algorithms that are being used to interpret the results from those databases. So I think each lab really needs to look at, what am I using? Is this new species even in my database? And if it is in my database, what happens when I do have this species? Can my system accurately identify it? Or is it still reading in so closely with Staphylococcus aureus, for example, that I can't identify it? And then once you know that answer, then you can decide, well, what am I going to report? Because you have options, right? So if you're not sure, which can happen, right, whether an isolate is Staphylococcus aureus or Staphylococcus argenteus, you could call it Staphylococcus aureus complex, and that would be correct. If you are sure that it's Staphylococcus aureus, you can call it Staphylococcus aureus. That's pretty straightforward. But interestingly, and Dr. Schuetz alluded to this, and this is something to think about as well. If you're sure that it's Staphylococcus argenteus, you need to be a little careful as well, because clinicians aren't necessarily going to know what that is. So you need to somehow in your report indicate that this is a member of the Staphylococcus aureus complex, so that they don't look at this species and think, oh, this is just an unusual species of Staphylococcus that's probably a coagulase negative Staphylococcus. This is in the minds of a clinician, right? i.e. it's not Staphylococcus aureus, and therefore likely to be clinically insignificant, or more likely to be clinically significant than if it were Staphylococcus aureus, more likely to be a contaminant, not deserving of serious consideration for treatment, and so forth. So the report needs to frame novel species as any report from a laboratory where you're reporting something your clinicians are not used to, with a little guidance as to what this is, because we worry that clinicians might misinterpret this as something not terribly significant, and that could lead to patient harm, which is somewhat ironic and backwards about what we were talking about before. So I think it's important to just think about what you can and can't do in the laboratory, and then what the reporting should look like on the other end of this. And it might sound complicated, but it's really not so complicated once you consider the variables here.
Well, definitely I want to thank you for your time. It was definitely very interesting. We were just, this came across that we were just sitting in the lab one day, and we were talking about different, how with MALDI-TOF, we're seeing all these organisms now that we haven't heard of before. And then someone said, it's like, do you know there's a Staph aureus complex? And then we're looking at it, and then it came to mind that I read this article in the summer, and I'm like, let me reach out, see if they can expand a little bit more for us. So really, thank you for taking the time for this.
Absolutely. It's a pleasure to be here. This work has changed the way we do things in our laboratory, and we report out these organisms. And so it's a pleasure to discuss this with you.
Glad to discuss it. Thank you.
All right. Thank you for your time. And that, my dear audience, is the end of this episode. I hope you enjoyed this wonderful interview with Drs. Patel and Schuetz. Some great information about Staphylococcus argenteus. As we begin the new year, continue bringing that motivation that you always bring to your workspace. Bring that passion to what we do. Such an amazing work we do. Hang in there. It has been challenging, but continue doing what you do best. And of course, please stay safe. Stay motivated. Stay safe. And of course, continue talking micro. Until the next time, bye.